Hello everyone, we are in section 3.3 and in section 3.3 we're going to talk about box plots. They're also known as 5-number summary. The objective of the box plot is to show the distribution of our data. Okay, so this is where ultimately we would like to go with this. We want to see the distribution of our data. Now, the numbers that make up the 5-number summary, 3 of those numbers are quartiles that we need in order to construct the box plot. And also I would like to remind everyone that we are going to use StatCrunch or any technology of your choice that you have access to and know how to use it. In order to do this, we do not wish to do this by hand. So I will show you how this is done by hand, and that is finding these quartile values. But then ultimately we will go to StatCrunch and have StatCrunch draw the box plot for us. So let's begin by actually finding these quartile values. Again, quartiles divide the data into 4 equal parts. So here in my example, actually, I have a set of scores. Okay, and that's what these are. Right in here. Those are 20 exam scores. And we need to find the quartiles for this set of scores. Now, the first thing we would like to do is we need to order this data. Okay, we need to sort it from low to high. And this is what I have here. Now, once we have sorted the data, the easiest way to find these quartiles is as following. We're going to find the median of the set of scores here. There are 20 scores here. So if I do 20 plus 1 divided by 2, I get 10.5. And that will be the location of the median actually. So what I need to do is I need to find the 10th score and the 11th score and average them to get the 10.5th value. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the 10th score. This would be the 11th score. So the average of those two is what the median is going to be. Now we found the median in section 3.1. So this is just a reminder on how we did it. And here's the score that we have for the median. Okay, pretty straightforward. Now, in order to find the other 2 quartiles, what we will do next is we actually look at this data that is divided into 2 equal parts. We need to find the median of the lower half and the median of the upper half of our data. And if we do that, we found the quartiles. Now, the lower half has 10 scores in it, right? So if I do again 10 plus 1 divided by 2, that gives me 5.5th score. That means I need to average the 5th and the 6th score. 1, 2, 3, 4. This is the 5th. This is the 6th score. The average of those two is going to be the median of the lower half. And there you have it. That would be 66 plus 70 divided by 2, right? 66 plus 70. That makes it 136. Then you divide it by 2 and you get 68. And that is how I got this number. Okay, and that's going to be Q sub 1. That means the first quartile. Now we're going to follow the same procedure to find the median of the upper half. The median of the upper half. So I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. Now we need to average 88 plus 92. The average of those two numbers turns out to be 90. 90. Therefore, Q3 is going to be 90. True? And that's how I found this number that's down here. Okay, right. Sorry, I'm not sure why my pen isn't working. Anyway, let me erase these. And there it is. Q3 is 90. So again, to recap, we're going to find the median of the entire data, then the median of the lower half, then the median of the upper half. Now, if you look at this and let's count, see how many scores lie between each tick mark, between each quartiles. So this is Q1, Q2, and Q3. There are 3 quartile values in any data set. Okay, these 3 quartile values partition the data into 4 equal parts. As you see, here's 1, 2, 3, and 4. Now, if I count if I count how many scores are in each segment, there should be equal number of observations. So in the lower half, I have 1, 2, 3, 4, 5. There are 5 scores here. And then the first segment of the lower half below Q1. Between Q1 and Q2, I have 1, 2, 3, 4, 5 scores here. Between Q2, Q3, I got 5 more, and I have 5 in the end. So this is what quartiles are supposed to do. They divide data into 4 equal parts. Each part holds equal number of observations. So if I had, let's say, 1,000 data points, 1,000, then divided by 4, 1,000 divided by 4 would be 250. Each segment would hold 250 scores. Okay, so that's what the purpose of these quartiles is. Now, and this is the run from StatCrunch. StatCrunch gives a 68 for Q1, median was 77.5, and Q3 was 90, which is exactly what we found using the easy way of doing this. Okay, so the numbers match against what we have. And again, we were going to use the StatCrunch when we do this. Okay, now let's take a look at something that we actually can get off of just Q1, 2, and 3, and that is interquartile range. We can actually use Q1 and Q3 to find the interquartile range, and that's what this IQR stands for. Interquartile range, or RQR. Now, the IQR, or interquartile range, is simply the difference between the third and the first quartile. Okay, so in this example that we just looked at, to find IQR, you just do Q3, which is 90, minus Q1 is 68, and the difference is going to be, 22, and that's how this number is obtained. Now, what does this interquartile range tells me? It is a range. It's kind of a high minus low, the idea of high minus low, except it's Q3 minus Q1. The interquartile range tells us, because if I look at the drawing here, this is Q2, here's Q1, Q3. Remember, 25%, 1/4 of all your data points lie in these sub-intervals. Okay, so if I look at Q3 minus Q1, okay, and in that range, there lies the middle 50% of your data, true? So it gives us an idea about the spread between the middle 50% of our data. One thing about this, an ordinary range that looks at high minus low, there's too much confounding because you're looking at only 2 scores. At least with IQR, you're looking at the middle 50% of your data. So the IQR is a better indication for the range and then just an ordinary range, because the ordinary range also sensitive to extreme values, right? But we're hoping that the middle 50% of our data, that is, shows more stability, and that there is not as spread out as the extreme ends of it, which is the max minus the minimum, right? Remember, the ordinary range is high minus low for the entire data set. So if I an exam score I have 100 minus another person got a 10, that gives me a 90-point range, which doesn't really tell me much about the rest of the scores. But the IQR for that same example actually is more informative. All right. Now, so we calculated the IQR, and now we're going to take a look at the box whiskers plot. So how are we going to do this? Well, this is the box whisker plot that I'm talking about, and this is a run from StatCrunch. So to construct this box, actually, here's how you can do this if you want to do it by hand. So you begin with a number line, and then you locate these minimum and the maximum. So this is a number line. So suppose this is like 30. I'm going to go 20 per tick marks. 30, 50, 70, and 90 here. This would be 110. Now the minimum score was 35, right? So 35 would be here. And then Q1 is 68, 68. This is the beginning of the box. There's 68. Q2 is 77.5. That would be the median. That's inside the box. And Q3 is the end of the box. Q3 is 90. And there we have it. So if I connect these lines, I get the box itself. And then the high score was 99, which is over here. Okay. And the whiskers come out from the end of the box. So from the left edge of the box out to the minimum gives you the left tail. And the edge of the box to the maximum gives you the right tail of this box whiskers plot. The reference to whiskers are right in here. Okay. And these are what we call whiskers. Like whiskers on a cat. Okay. And of course, this is the box itself. So together they make up the box whiskers plot. Okay. And this is how you do this by hand. See, it doesn't take long to do it, but then we'll look at looking at the stat crunch for a better drawing. Okay. Now, hopefully you know how to do a box plot now. So, what does the box plot tell us? We use box plots in order to get a visual for possible shape of the distribution of our data. Okay, so let me show you how I can do a sort of a histogram for this data. Okay, now the histogram, any histogram that you do based on a box plot is going to have only 4 bars in it. Okay, 4 bars. So the first bar, this is going to be the width of our first bar. It's going to go from here to the edge of the box. And then the median is right here. That's where the second bar is going to be. And this will be our third bar. And this will be our last bar. Okay, so the first bar in this histogram is going to go from here to here. Okay. Now, the height of the first bar is not important, okay? It's not important because I don't know how high to go. So, we actually have some flexibility on the height of the first bar, okay? So that's number 1. Let me actually draw the height of the bar at, let's say, about this high, okay? Again, that's just a random height. It doesn't matter, you can go higher or lower. However, everything that we do from here after, it's going to be relative. 25% of information is in this segment. So if you think about these 25% as an area of this rectangle, in this next rectangle I'm about to construct with this width, the height has to offset so that the area is exactly the same area. Remember, equal number is in each segment. So I'm going to make this bar, it has to be higher, right? Because it has shorter width, it has to have longer height in order to hold equal number of data points. The next bar, look at the width of this one, and the one next to it is slightly wider than this bar, but then it's shorter than the first bar. So that means this second or third bar is going to be lower than the middle one, the second one, but taller or higher than the first bar. And finally, if I look at this last bar, this one and this one are almost equal. I'm just going to go equal height, just about. There you go. And that's going to be the histogram for this data. So you see how we have a perceived histogram based on the box plot, and that is primarily what we use for box plots. Now, once we get more comfortable with box plots, you'll be able to actually graph these distributions without drawing the histogram. Because remember, what we do on a histogram is we try to throw in a smooth curve on top of that. So when I see a box plot like this, we're just going to say the distribution is going to be skewed to the left because the longer whisker is on the left side, which gives it the bigger tail as it is apparent from the histogram. Okay, so this is how we're going to do this. Now, StatCrunch doesn't give you the histogram of a box plot, but we can get that ourselves. So now let's take a look at some example of box plots and the corresponding distribution of the variables. Okay, so the first box plot, that is, in the first box plot, actually we're looking at the distribution of a variable that is uniform, a uniform distribution. And the reason this uniform is if you look at the box plot, I'm looking at this box plot right in here, okay, the top left. If you look at the segments, they have equal widths. So here's what I mean. Look at the distance. As you can see, the distance from here to here, okay, here to here, here to here, those are all equal distances, right, which they transpose into the histogram. Okay, those equal widths, and the box, of course, starts at Q1 right in here, middle Q2, and Q3 is here, and then you draw the box. So this would be the box plot of a distribution that is uniform. Okay, look at the one next to it. You have the box plot for a distribution, the normal distribution we call this. For that one, you have these two whiskers right here that correspond to that area under the distribution, and of course the center of the distribution is where the median is here. And look at this middle piece. Now you have a bigger concentration. You have 50%. That's 25 in each segment, totaling 50% of the data. The other 50% equally distributed, 25% on each tail. Now this box plot, try to keep this one in mind, okay, as we go through future chapters. A lot of our procedures assume that we have a distribution of a variable that is normal. So if that is the case, then our box plot should look like the one for the bell-shaped. And then we get into these skewed distributions. See the longer whisker to the right? That's indicative of a right tail. The longer whisker on the left, indicative of skewness to the left of the distribution. Okay, and that's how we interpret these box plots. Now look at, for example, again, the one that's in here, and look at the one that we have. You see how similar they are? The longer whisker on the left, longer whisker on the left, also in this group of box plots. Let's take a look at an example. In this exercise, this is number 130 of in your textbooks. So this one, they're looking at the salaries of two different majors, two different graduates, different majors. One is business. The top one, right, is for business graduates. So this is for business graduates, and the lower ones are for liberal arts graduates. Liberal arts. Okay, now the question reads, use the box plots to compare starting salaries. That's a starting salary, right? Minimum is a starting salary of the graduates in the two disciplines, two fields, and then special attention to center and variation. Okay, the variation we're talking about are in two ways. One is in the way of IQR, interquartile range, and the other variation is range, which is on the high minus the low. Okay, that's what that is. Now, if you look at, again, that would be in the way of answering the variation. The center of the data, of course, we look at the median. So we want to compare those. So let's begin, first of all, as the question asks, comparing the starting salaries. It looks like the starting salary is a meager $25,000 a year versus almost the salary here that is about $37,000, right? And one thing that's interesting is that if you look at the minimum starting salary of a business major, that's almost the same as the median of liberal arts major. That means from the get-go, a business major salary, the person an entry level makes better than 50% of liberal arts majors. So the minimum definitely lower, right, for liberal arts. That's this number versus that number, much lower. We're looking at again 25K versus about 37K. Difference of almost $12,000 a year. That's 50% more in favor of business. Now, let's look at the range. High minus low, that's about 50 to about 37. That's 50K minus 37K. That's $13,000. Right? That's the range of the salaries for business majors in the $13,000 range. The IQR, and this is R for range, the inner quartile range, the middle 50% of salaries for business majors lies between these two numbers, which is about 43 to 46,000. So I'm just guessing these out, right? It's 3K. You see how it is less variable in the middle than it is on the outskirts, right, at the extreme points. Now let's compare those for the liberal arts. Okay, for the liberal arts, the range is going to be about 44K minus the minimum of 25. So they're in a $23,000 range versus 13,000. So it's more widespread. In other words, the salary numbers are very highly variable. So there's no guarantee you'll make the median, which is about 37K. Okay, because the spread is so high. Let's look at the IQR, the middle 50%. The middle 50%, this is almost 40K. That's about 34K. So the IQR ranges in almost 40 minus 34 in a $6,000 range, which is much better than $23,000 range. But compare that range to this one, the IQR. So the business majors have even a lower IQR. So the spread of the salaries are less. That means those measures of salaries that we call out are more indicative of what in actuality could happen if you were to go out and look for a job as a business major or as a liberal arts major. Okay, and the notable thing was right in here to me. It's interesting how a starting salary of a business major is better than 50% of those in the liberal arts. So it looks like it's a better degree to hold from what I see from this diagram. Okay, from this from this box plot. And that's what the box plot does. Now, if you look at the distribution of these, look at also the distribution. Look like distribution of liberal arts major salary is skewed to the left, and the distribution of business major is almost symmetric, isn't it? Remember how this looked like for a normal distribution? We're not too far from it. Look at this one, and look at for business majors, the one that we see here. It's almost normal. In fact, actually the longer tail is on the left, isn't it? So slightly longer tail there. It's more of this distribution. So it is almost symmetrical distribution. That is good. We like to work with distributions that are symmetric and bell-shaped. Okay, and there you go. So that wraps up this one. Now let me go to StatCrunch and actually show you how to do this in StatCrunch. Okay, so I am in my MATLAB, and here is a StatCrunch on the left side, lower left. Click on that, and that invokes StatCrunch. Okay, now I already have StatCrunch running, but that's how you get to StatCrunch. And if you click on dataset from your textbook, you get what I got here. There you go. This is what it's going to look like. Now, I went ahead and input the data for the exams, right? The made-up data that I have of my own. So I went ahead and put that data in there. So let's see. First of all, how do I get the quartiles? To get the quartiles, you go to Stat, Summary Stats, by columns, and click on Exam as your variable. And here I'm going to choose, I'm at the lower, in this gray area. Go down, and first I'm going to choose the median. Okay, so here's, by the way, Q1. Left click once, hold the control button, and go down. This is Q3, and further down, mode, I'm looking for median. There you go, median. And all you gotta do is just hit compute, and this is what you will see. There you go. Those are the values. Now you get them in the order that you click. Okay, so I click Q1, Q3 first, then median, so it gives me in that order. If you click on Q1, median, Q3, then you get them in exactly that order. So those are the values of them. Okay, now let's draw the box plot. To do the box plot, you go to Graph, and in here, let me enlarge this if I can. Looks like I'm not able to enlarge this, maybe. Okay, you go to Graph, and then you go to Boxplot. Click on Boxplot. Choose a variable, left click once, Exam. Okay, and then down here under other options, it says draw box horizontally. If you don't, it's going to draw it vertically. I like horizontal box plots myself. That's just like the example we did. And the reason, because I can connect to it better using the number line, because the number line goes in a horizontal direction. So I can quickly project minimum, Q1, median, Q3, and maximum. Those are the 5 numbers. Now it gives you an option for markers between mean and the median. I'm just going to put a marker for median. This is optional. You don't have to. You can activate or deactivate it. If you do it, then it'll show in red. And that's it. And then, oh, right in here, you see these fences to identify outliers? In the book, he talks about these extensively, gives you formulas for it and stuff. Don't worry about the formulas for fences. But I'm just going to click it here and then hit compute, and there is the box plot, okay, that I had. And this is the median in red, which I checked. Okay, so if you uncheck it, you won't get that red line there. And that's how I got the box plot that you saw. If you hold over this, your mouse, I'm not clicking, I just kind of slided the mouse over that number. It gives you the 3 quartiles, gives you Q1, actually gives you all 5, doesn't it? It gives you the lower limit, that's minimum, Q1, median, Q2, Q3, and upper limit is the maximum. So it gives you all the numbers, and anywhere you click, it gives you the same information. You see that? There, anywhere in the box. That's good. So you don't have to guess at, oh, okay, what does this look like here? You just hold it, oh, okay, that's at 35. Where is this number, Q1? Well, Q1 seems to be at 68. That's where this is. You see that? And it gives you the IQR also, 22. And number of scores, 20. Very informative. Now, let's see. There is no outlier in this one. But if there are outliers in a box plot, they will be illustrated using a dot. Okay, so let me actually create an outlier here. I'm going to change my data. I'm going to put a score of 5. Suppose somebody scored a 5 on that exam. That clearly is separate from everyone else, isn't it? Let's redraw the box plot of exam, and I'm going to draw it horizontally, and I'm going to use fences. Okay, these fences are literally just like fences in a correctional facility. Any score that jumps the fence is a bad thing. Okay, it's like a prisoner escaping from the prison premises. Okay, jumping the fence. So look at that left blue dot. Okay, we're looking at this dot right in here. You see that dot? So that's a score of 5. This score is an outlier. Okay, so what happens? Well, as you can see from StatCrunch, this is marked, and then if you leave the fences out, you say, in fact, in a moment, let me do that. Let me uncheck the fences and see what happens to the shape. I'm unchecking the fence. Now you're going to see this whisker stretch all the way to the minimum, and the minimum is 5. And there you have it. You see that? That long whisker, which makes this really skewed to the left now. Changes the shape of the distribution quite a bit. Now, we don't like to be misled by just one score. So what's going to happen is once I choose the fence option, this score of 5 would be an outlier. And then you're going to see the next higher point than 5, the next larger value is 35. I'm going to go options, edit, and use fences to identify outliers, and compute, and there you go. So there you have it. But in the original data, we did not have the score of 5. I just want to show you how that outlier option works. In your exercise, there's a question that will ask you also the same thing. It may even give you one with an outlier. So I went ahead and removed my outlier here. And there you have it. So this is all we wanted to talk about in this video. We learned about the 5 number summaries. Those 5 number summaries are minimum, Q1, Q2, Q3, and maximum. And we learned about the box plot. The box plots aid in looking at the distribution of our variables. And with that, we are done with this section 3.3.